Hello friends. Today we will see some of the basic of calculation in R. Okay. So in basic calculation with respect to matrix operation in R. Fine. Okay. Now as we know, we have already installed R Studio. So how you can go to R Studio, as I told you, where you just go to R and just open the R Studio. So R Studio will open. It will take some time. Okay, as soon as this R Studio is open. So this R Studio will have, see, 4 sections. Okay, one of this section is called as the code, where you write the code. Okay, so this is R code terminal. Okay, where you write the code. Here this is a place where you write the code. Now this is a place, this is called as console or terminal, where you can execute the R command. And this is called as what? It will have the history or environment variables. All information will be available in this particular window. Okay, and this particular window is specifically dedicated for all the files history, all those files which are available in a particular folder, new folder, any packages if you want to install, or if you want to see the packages which are available, you can see all those packages from here. Okay, or if you want to update also, you can update. Just select the packages which you want, you just select those packages, and that packages will be available for your execution. Okay, yeah. So we will practice all those matrix operation over here in R Studio. Okay, first of all, what I will do, I will execute this Control L. This will clear all my previous history in the terminal. Okay, now what I will do, as I told you, how you can create a matrix. So this is an object which I have created. Okay, we will assign what? A particular matrix. For that particular, there is a matrix function is available. Okay, and you can allow some a dimension to the row. Okay, you can allow some dimension to the column. Okay, once you allowed this dimension, now you will allow some data. So these are the data which you can assign to this matrices. And C stands for combine. You are combining this value. How many value you require? Because it is a 2 by 2 matrix, so it required 4 value. So I will take what? 1, 2, 3, and 4. Okay, fine. Okay, so this is done. This is your this vector is closed. So this is called as a vector. So this vector is closed and this particular matrix is closed. Now this is done. Now I want to execute this. So this is my R code for creating a matrix. Now I want to see this particular output of this matrix. So my output will be seen when I will run this particular code. For running this code, where I will go here. Here, can you see this? There is a run menu or run option is available. Okay, yes. So when I enter this run option, you will get an output. Okay, it is executed. Run, when I click that, it is executed, and I know that my output is present where? My output is present in X. So what I will do, I will press X. Okay, I will enter X. Okay, I will enter X over here. Okay, and I will run this X. I will run this X. Okay, so as soon as I run this X, I will get the output. So this is my matrix. Okay, so this is matrix, and if I want to see the dimension stands for, this will give you how many rows and how many columns are there. I will execute this. Okay, I will execute this. This will see the output. This is 2, 2. 2, 2 means 2 row and 2 column. Now if you want to see how many rows are available, okay, to find the rows, what I will do, I will write here row of X, n row of X. So I will write n row of X, that will give you the row. If I write n call of X, it will give you the number of columns. Okay, so what I will do, I will execute this. I will execute. So you will get 2. This is 2 represent what? This 2 represent a row, and I will execute this. This means this is a column, and this will represent the number of column. Okay, so this will give you the output in this particular matrix, how many rows are available, and this will give you the output, how many columns are available. Okay, so these are the functions which are available in R. Okay, while dealing with data science, you require such functions when you are dealing with a huge volume of data, or whenever you want to predict some output, okay, whenever you want to predict some output based upon some data, so you require this type of functions which are very much important to do the prediction or to understand the market trends. Okay, you can easily understand the market trends. Apart from this, you can also have this mode. I told you what is the use of this mode is generally used for finding out which type of data you have in this particular matrix. Okay, so usually you have a numeric or character. Okay, so I will execute this, I will select this, and I will run. When I select and run, it will give you a numeric. So numeric means what? This is a numeric data. Okay, fine. It will also show a character if I store that character data, if suppose this data is numeric. So that is why the mode of X is numeric. But instead of this character, instead of this number, if I store a character data, so this will give you what? A character. The mode will be the character. Okay, but here the mode is what? Here the mode is numeric, because the data which I have stored in a matrix it's a number. As the data stored in the matrix is a number, the mode of X will be numeric. Okay, but if I store here the character, the mode of X will be character. Okay, now apart from this, I told you how you can take help. Also I told you that there is a help function is available, help on a particular matrix. Okay, help on a particular function, help on this particular function. When you insert this, when you execute this, it will give you the helps which are available. These are the helps. You can see this. These are the helps which is available. Okay, you can see the help, and you can write accordingly. You can write the syntax of matrices by looking at this particular help. So this option is available to take the help from the RStudio. Okay, now we will also see that, suppose I told you the data, if you know the data is what? If you know that data is, you want in a matrix all data should be 2. I told you that how you can have that. For example, Y is an object, matrix. I will say what? N row equal to 2, and n call equal to 2, and I want that in that all should be a fixed data. All should be fixed data. So I will take 2. Okay, I will take 2. Now what I will do? I will execute this, run this. So you will get an output. See, if I press here Y, after this, press Y. This is an object. I will run this. So you will get what? See, 2, 2, 2, 2, 2, 2. Can you see the output over here? 2, 2, 2, 2, 2. 2, 2, 2, 2 means what? Because I put all data in 2 by 2 matrix, the complete data is 2. So that is why you get 2, 2, 2, 2, 2. Understood? Similarly, you can also have a particular matrix. For example, if you want to have a diagonal matrix. Okay, so for diagonal matrix, I told you, if you want to have a diagonal, if you want to give value to a diagonal. Okay, so whenever you want to give a value to a diagonal, what I will do, the value which you want in a diagonal is 1. Okay, and what is the row capacity is 2, and what is the column capacity? The column capacity is 2. Okay, so D. So I will execute this first, that run this first, and then I will run this first. So you will get what? See the diagonal. Can you see the diagonal? Okay, now apart from this, I also told you that the data which you have took is what it is. By default, it is what? This is a column wise. The data which you have took is a column wise. But if you want a data a row wise, for that you want to make some changes. What you will do? X equal to, what I will do? You have a matrix. And then I will take some row size. The row size is 2, and call size is 2. Then I will take the data. This is a vector. Okay, vector. I will take, say, 1 to n. Okay, I know that the vector, the data which I want to take is what? 1 to n. So this is 1 to 4, because 2 by 2, 1 to 4. So I can take directly value from 1 to 4. Okay, now I want it in a row, by row. Is it you want it in a row? True. So the data will take, you see the data. This is this data. If you compare this data, now, so this data is not, it is not, see, it is a column wise. See, 1, 2, where it is there, it is in the first column, and 3, 4, it is in the second column. So I want to change this flow. You want to change this flow. You want to change the flow of storing the data in a matrix. So in that case, what I will do, there is a one parameter that is called as by row, which is equal to t. So now in this case, the data will be stored in the form of a row. Okay, so I will execute this, okay, and then I will execute this. You will see the change. Okay, you can compare this data, see 1 3 2 4, and you compare this data 1 2 3 4. Okay, this is 1 3 2 4, this is 1 3 2 4, because the data is entered in a column wise. Here you will see the data is 1 2 3 4, the data is entered in the form of a row wise. Why? Because I have added one more parameter. What is that? By row equal to t. So as I added this parameter, the data which will be stored in a matrix, it will be changed. Okay, and as I told you, if you want to do the transpose of that, okay, there is a function which is available. What is that? Say t of x. So t of x will, what it will do, it will transpose the data. Okay, so I will execute this, and I have to see the output also. To see the output, I will use xt. So I will execute this, I will run this, okay, and I will run this. Okay, you will see the transpose of this. Okay, how do you know it is a transpose of that? Because you want to see the x. So what is the x? See, 1 2 3 4. Now the data is 1 3 2 4, because the row has become now column. See, this is my row. This row has now changed to column. This row has changed to column. So this has been changed to column. So this is what transpose does. Okay, then we have also discussed about, we will discuss about some matrix multiplication. Okay, for matrix multiplication, suppose if you want to multiply a matrices, we know that we already have a x. In x we have this matrix. So if you want to multiply, you want to do the multiplication, so I will create a m object in which I will multiply 3 with x. For multiplication you will use star. Okay, so 3 with x, and I will press n. So I will execute this, I will run this, okay, and then I will run this. So you will see the output. So this is what is a multiplied. The every element of this is multiplied by 3. 3 1 ja 3, 3 8 minute. I have multiplied with what? I see, you have to check it out. Okay, I have multiplied with 3. Okay, but I have not multiplied with this transpose. This is a transpose matrix. Okay, I have multiplied with this. This is x. Okay, see, 3 multiplied by x. So 3 1 ja 3, 3 2 ja 6, 3 3 ja 9, and 3 4 ja 12. Okay, we are not applying to this transpose matrix. We are applying to this x matrix. Okay, that's why you get this value. Okay, fine. So that also. Now, suppose you want to do matrix multiplication. I told you for a matrix multiplication, how you can do that. Suppose you have a y matrix. Okay, you have a y matrix. Okay, see, I will check it out. What is the matrix you have in y? So this is y matrix, and I also check the x matrix. Okay, so this is my x matrix. I will run this. This is my x. So this is my y, and this is my x. Now I want to perform this matrix multiplication between these two matrices. What I will do, I will store it in some variable. Say, I will say k. K is an object where I will store this matrix result, matrix multiplication result. So what I will do, I will multiply y with what? I will multiply y with x. I cannot do this directly because it's a matrix multiplication. And in R, you have to remember, whenever you want to perform a matrix multiplication, so in that case I have to use what? Mod in front of the asterisk and mod after the asterisk. So when I use this mod front of the asterisk and after the asterisk, so this will give you the matrix multiplication of these two values. That is y multiplied by x. So this is the result. You can check the result. I have to run this. Okay, I will run this, and I will run this also. Okay, run this also. You will see that the result, what you get, is matrix multiplication of these two. It's matrix multiplication of y and x. Okay, but you can have one more method through which you can do the same thing. What is that? You can do that. That is cross product. Okay, that is cross product. Okay, so cross product, PROD, cross product. Just I have to write what? I have to write what? A variable. So this is what? This will multiply. What it will do? It will multiply x with the transpose of x. Okay, so it will multiply X matrix with the transpose of X. So it will give you the same. It will give you the result. Okay. Okay, I will run this. I will run this, and then I will run this.